So let me just start off by showing the regression, how to run the regression. Go to Data Analysis, Regression. Okay, if you don't have this, Google on how to. That's a free add-in for any version of Excel. My Y range. This is the variable I'm looking at predicting. So I go ahead and put that in here. My X range, all you have to do is select the entire block there, make sure all your variables are together and everything's already in the right form numerically. And then you just check labels, because I included labels, and you should. Press OK, and we get our regression. So let's focus a little more on how to interpret. We've interpreted these parts already. What we haven't looked at is this block right here. So let me start by looking at the predictor variables. Notice that the outcome variable is not here. This entire thing is talking about the average minutes of deep sleep I get per night, but the only ones we're going to see here are the predictor variables that I think might be somehow related to the amount of deep sleep I'm getting. So this is the time I'm going to bed at night, how late. This is if I'm the last 20 minutes of the day, am I reading a book or am I watching YouTube videos? Did I take a nap that day? Girls crying, the fan speed, fruit snack, caffeine. Did I have caffeine after, I think, noon is what I was looking at. Salty snack after 7 p.m., which I often do. And this is the Korean word for going to the bathroom. So how many times did I pee during the night? So these are all things that I had previously identified as maybe having an impact on my deep sleep, so I wanted to measure them. And now I'm actually going through and taking a look. So in order to tell whether or not, or the degree to which they may be impacting my sleep, I go to the p-value column first. As always, the p-value is, the lower it is, the more evidence against the null. So what is the null in this case? Well, each of these has its own little miniature null. There's a null hypothesis for the entire model. Is the entire model, the null would be that it doesn't help predict deep sleep whatsoever. But then we also have little tiny individual nulls. Does the null here would be the time I go to bed has no impact whatsoever, is not even connected to the amount of deep sleep I get. Reading versus screen time, no relationship whatsoever with my average amount of deep sleep, and so on. So when I see big numbers here, in plain English, that means probably that particular factor is not closely connected with the amount of deep sleep I'm getting. So for example, the fan speed, I use that for white noise sometimes, that doesn't seem to be very connected. This one is an interesting one. I want to focus on this one just a little bit. Also, this one, looking at the p-value, would think add this number of times I go to the bathroom isn't much related to my deep sleep, and that to me was strange at first until I started to think about it. In fact, let me just run a quick analysis regression. Why not? We get our Y range there. For the X range, the only difference is I'm only going to take this single variable and run this. So notice here, if I only put urination in the model, I get a 0.65, which is a little more, not much, but a little more convincing evidence that the number of times I go to the bathroom might be related to my amount of deep sleep getting. So why is that number different than this number in particular? Why is it stronger evidence? Why is the 0.65 stronger evidence that this number of times I go to the bathroom is related to my deep sleep? So in a multiple regression model, the really cool thing is that you get a sense of isolating each variable one at a time. And let me explain what I mean by that. What I'm saying is this p-value here is saying, taking all of these into account. In the literature, we often see the words controlling for wealth, controlling for age, controlling for biological sex, controlling for previous heart conditions. So here I'm controlling for the time I go to bed, the screen time choice, the nap, and so on. On top of all those, if all of those are exactly the same, so let's say I take 2 nights, Wednesday night and Thursday night, and on both those nights I go to bed at exactly the same time. Both of those nights I either choose to do screen or both nights I read. Both of those days I either took a nap or I didn't nap. The point is, on both of those days I was exactly the same on all of these. The only difference was Wednesday night maybe I go to the bathroom twice during the night, and Thursday night maybe I didn't go at all. What we're saying is, if these are all the same, controlling for these, then we're pretty sure that the number of times going to the bathroom doesn't make a difference. Now, if I just look, why do I have stronger evidence if I just look at going to the bathroom? That's because there's all kinds of lurking variables here. This is exactly why we can't say correlation equals causation, because it is true that going to the bathroom is a little more highly correlated with my average deep sleep. But once I start putting these things in the model, that relationship it wasn't even strong to begin with, but it's much less strong than we even thought. And I'm going to put forth a potential theory there. Caffeine, when I drink caffeine, especially later in the day, then I'm going to go to the bathroom more. So those nights that I go to the bathroom more, maybe I get less sleep. Maybe that's not necessarily because of the bathroom itself. Maybe it's because of the caffeine in my system doing other things. I'm just putting forth an example theory. The point is, these things are now all controlled for. So if they really were lurking variables in between the relationship between going to the bathroom and deep sleep, now they would be controlled for. Let me go back to last week where we talked about regression and causation. If you could truly find all the important lurking variables and include them in the model, and then when you looked at a variable and you saw a significant result, what you've just shown there is essentially causation. I mean, you still need to make sure it makes logical sense, that this comes before the outcome. There's a couple other things, but essentially that's what it means to take correlation towards causation through regression. It's putting those lurking variables in the model so that we can say, if these are actually equal, then is there still a difference in outcome based on different levels of whatever this predictor variable is. So I do notice that some of my lower p-values here, and granted these aren't all under 0.05, and if I did Bonferroni corrections, none of them would be under 0.05. Matulsky does make a good point that with every predictor you add in a multiple regression model, you really should add a sample size of 20. So I really should be looking at 200 nights worth of data. But this is life. I lost my Fitbit after collecting this data. This is the data I have for right now. Ideally, later on, I can continue to conduct targeted experiments or tests on some of these. But this can give me some preliminary suggestions of, looking at this, I can be fairly sure that probably the fan the fan speed is not really influencing my sleep. Whereas these are more likely culprits, and really even the fruit stack. That's getting a little higher, but still nowhere in this range here. Now you notice I didn't highlight the intercept. In most cases, we don't really look at the p-value for the intercept, and I won't go into detail with that, but right now we're just looking at the predictor variables. Okay, so now let's talk about what these mean. So I do have evidence that some of these factors might be pretty important. How do I make an actual prediction. How does this stuff here work? How does this is really my regression model. How does this work? Well, I could write an equation that would be predicted amount of sleep equals my intercept plus this times this plus this times this plus this times this, and that's how you see it in articles, in research articles. You'll often see a Y with a little caret on top of it, and then you'll see it looks like a fancy B. It's the Greek letter beta times a number, and then this and this and so on. And that's the regression model. There's a really neat trick. If you have this regression output I want to show you, if you just grab those first two columns, and I'm going to cut them and paste them, there's a neat way where we can make predictions. I think it's a little easier than writing out that entire model. So what I'm going to do is I'm just going to replace each of these with a particular value. You could do it with your own. It's not necessarily going to generalize to you, because this entire study is really about my body, the uniqueness of things relative to my body. But if you want to go through it for practice, it wouldn't be a bad idea. I'm just going to go through for last night. So last night I went to bed at 12:30, which would be 150 minutes after 10 o'clock. I'm just going to type that in as a number. I didn't read. I watched YouTube videos. So that would be a 0. Nap the previous day. I did not have a nap yesterday. That would be a 0. Girls did not cry last night. I actually did not have the fan on last night. I did have a fruit snack last night. Caffeine, no. Salty snack after 7. I did not have one of those last night. And I did get up once to go to the bathroom. So those were what I did there is I put my value in for each of those variables. And now if I want the predicted, this is where it's really at. I'm going to predict how much sleep I got last night. Well, I start by just pulling this intercept over here. I just copied that. And for every other row, what I'm going to do is I'm going to take the slope for that variable times my value on that variable, press enter, and I'm just going to drag that down. That's going to give me a bunch of zeros because these were 0 times this. That's okay. And then most importantly, I'm just going to add up all of this. So that gives me predicted on nights where I make those same decisions or I have those same scenarios. On average, I'm going to get 60 minutes of deep sleep per night. And of course, there's a confidence interval around that, but that's my best guess, that an hour of deep sleep based on those. I can also take a look. I mean, the getting up to go to the bathroom didn't really decrease my predicted average much. Now I'm having to go back. The fruit snack maybe took a little bit. Going to bed late there, according to the model, was one of the biggest issues why I would have such a low predicted time there. So looking into those a little more specifically, these slopes are pretty meaningful. Let me just take a look at caffeine. If this has a value of 1 versus a value of 0, look what happens when I put a 1 in there. Suddenly, on average, I get a predicted value less, 20 minutes less of sleep. Let's say I took maybe I did reading instead of screen time, which is right here. I would get an additional 13 added on. That's a positive thing. So anything that's a positive here is going to predict more sleep. Anything that's a negative, it's going to mean I get less sleep. And the number itself, you have to be a little careful of saying, oh, just go for the big numbers, because here this is per minute. Per minute later I stay up, that's an extra 4th minute that I'm not getting average deep sleep. Now, is that a cause? that's where we have to start controlling for these lurking variables, thinking through it. That's a much more difficult decision. But in terms of predictions, based on what we've seen so far, for every extra minute I go to bed, I lose 15 seconds of sleep.